In this video, we will generate the dataset of the LOGIT function and its Taylor-Maclaurin SERIESSUM expansion and regress it to the sixth degree. We begin with the use of array formula. Ln. Let's start with the 1 over or ln x. Ln of x of the x values. And that's x over 1 minus x. So that's ln of x over 1 minus x. So that's the formula, the trend line, and the data set. Here you have 5.01 plus negative 5.01 plus 48.3x minus 196x squared. Let's calculate this using the LINEST. So we have our n starting with 1, 2, 3, 4, 5 to the power 6. So we enter array formula of the x values, all raised to the power 1 to 6. So we have now the LINEST data y and data x. This time we'll use the from x to the power 1 to x to the 6. Enter. And let's verify the output. So our B0 is negative 5.01, B1 is 43.8, which is 43.76. B2 is negative 196.24, rounded up as negative 196. B3 is 447.56, rounded up as 448. And B4, 475, negative 475. Our B5 is 190. And our B6 is, well, this is already rounded up as 0 because that's 3.3 times 10 to the minus 14. Now let's continue with the Taylor-Maclaurin series sum. So it is logarithm of x plus the summation of a times x to the power n, where the a is 1 over n, and the value of n starts from 1 to infinity. So we have 1, 2, 3 until infinity, but we can only reach what we have, 14. So we start with the series sum. So array formula, series sum of the x values of a of the x values raised to the power. Now our n is from 1 to infinity, so 1 and incremented by 1, and our coefficients will be that range. So we'll calculate the coefficients and also we'll factor in the ln x. So ln x, that's ln plus and the x values. So we have the ln x values. And we'll add in the coefficients, which is this area. And the coefficient will be array formula 1 over n. So the value starts from there. There's a match up to this portion, and then the error begins at point 0.3, 0.5, and 7. So there's a split ends on this further on as x approaches 1. Now let's calculate the coefficients, the regression coefficients, because there's a match of the regression coefficients. So we'll use the same one comma the x matrix. So is LINEST data y and data x. So we have a match on the coefficients. That's negative 5.03 for B0, B1, 45, and 43. The slight error, but the error increases. That's why there's a split end. So this shows the LINEST polynomial regression of LOGIT function and the Taylor-Maclaurin series sum of the LOGIT function.